Alright, welcome back everyone. This is the second part of week 0, part A. It's split into 2 parts because otherwise uploading it to YouTube is a bit of a pain. So that said, let's go ahead and start talking a little bit about what the programming process looks like. So one of the most common misconceptions about programming is that it's just writing code. Programming is a lot more than just writing code. There's a whole phase of steps that you have to sort of go through to write code that makes sense. So let's go ahead and talk about the overview of the programming process now. And I encourage you throughout the quarter while you're working on assignments and in the future when you're working on your own code outside of class potentially to reflect back to this overview of the programming process and make sure that you are going through every step of the process. Alright, so let's go ahead and talk about these stages. Something that I will note, these stages are presented slightly differently in our textbooks, but they all cover the same sort of general ideas. Another thing I do want to mention about these stages, they're not necessarily ordered. In fact, generally what will happen is you'll jump in between these stages as you're going through the process. But generally you do start with the design and plan phase. So something that I will encourage you to do throughout the quarter, especially as we get more advanced throughout the weeks, is when you get an assignment or you get an inspiration to code something, instead of just diving into the coding right away, take a little bit of time to design and set up sort of a game plan for what you're going to do. So part of the reason you want to do this is because, one, programming is new to all of us, right? So you don't want to just dive into it right away, because there's sort of 2 steps of writing code. There's the step where, yes, you have to write the code and actually type in our case, the Python code to get the thing to work. But you also have to think a little bit about what is the sort of steps behind making it work as well. So you do want to take some time to think about this design and plan phase. Best way to do it is to plan on paper first. So again, before you start writing code, just plan some stuff out on paper first. You'll sort of develop your own way that makes sense for you. 2 common methods for doing this are writing pseudocode and designing flowcharts. So pseudocode is sort of an in-between writing bullet points, sort of an outline in English, and writing the actual code. Pseudocode means fake code, so it's sort of the in-between of that. Flowcharts are more of a visual representation of a plan, so if you are a visual person, flowcharts might be your jam. That said, both of these are covered a little bit more in the textbooks, so definitely check that out. The main sort of idea behind this design and plan phase is that you want to figure out the algorithm before starting the code. Alright, so let's talk about algorithms. So algorithms are a sequence of steps that together solve a problem. Now this is pretty similar to what a computer program is, right? We talked about that earlier. Computer program is a series of instructions that you give to a computer to solve a particular task. Really, the only difference between that and an algorithm is that an algorithm isn't computer specific. You'll see in this definition that there's no computer in it. So algorithms are something that exist in any field and even in your day-to-day life. So for example, tying your shoe, right? That's an algorithm. It's one big task that you have to do, and there are a bunch of smaller tasks that you do to accomplish that task. Another algorithm would be baking a cake, right? You have your ingredients and your recipe, and based off the recipe, you use these ingredients in a certain way, a certain manner, certain amount, certain steps to hopefully make a cake that is tasty. Couple things of note about algorithms. So algorithms should be these 3 things. They should be unambiguous, meaning There's no guesswork involved. So for example, with the baking a cake analogy, let's say your recipe says add flour to mixing bowl. That's a little bit ambiguous because how much flour are you supposed to add, right? So the idea behind algorithms is you need to be as specific as possible. There should be no guesswork, there should be no guessing involved at all. So instead of saying add flour to mixing bowl, you should say add 3/4 cup flour to mixing bowl, for example. Algorithms should also be executable. This just means that they need to actually be able to be carried out in practice. So for example, with the baking the cake, if I say pour 3/4 cup flour into mixing bowl, you better have that flour on the table, on your counter in front of you, right? So whenever you get to any step in your algorithm, you have to actually be able to do that step. And the way you are able to do that step is hopefully your previous steps have set you up so that you are able to accomplish the current task that you're on. Another thing algorithms should be is terminating. This means they have to end at some point, and this might seem sort of self-explanatory, but it is important to mention. You know, the idea behind an algorithm is that eventually you accomplish some larger task. That won't happen if you are continuously doing things forever and ever and ever. So at some point the algorithm has to stop. There has to be some sort of end point, end goal, where you reach the final accomplishment of your task. Alright, so after you've done your designing and planning, you've thought about your algorithm, you've written out notes for yourself on paper, whether that be in pseudocode or bullet points or a flowchart. Next stage is writing and debugging the code. I'm not going to talk too much about writing code today because, well, that's what we're doing all quarter. I am going to talk a little bit about debugging today, and we will talk more about it next week. But let's talk about the terminology behind this right now. Alright, so a bug, this might be a term that you've heard before. A bug, all it is an error in code. So something that's wrong with your code, with the program. Then debugging is the process of removing errors from code. And here's the thing about programming. Debugging is a very common thing to have to do. In fact, I would say 70% of writing code is just debugging. So it's one of those things that it's a little bit weird because when you hear the word bug, it's associated with this word error, right? Which is associated with the word failure. But I want you to, as you code stuff for this class, when you run into bugs, I want you to celebrate your bugs, because running into a bug means that you are programming. It is just this inherent part of programming. You hit a bug, you'll eventually fix it, I promise. And then when you run into that bug again, you'll fix it much faster than you did the first time. So get ready to celebrate your bugs. That said, I do want to give a short little history lesson. I'm not going to talk too much history in this class, but the term bug does have a fun little history that dates back to the 40s. So again, computer science, a relatively new field, right? So this is a term that dates back to 1947. Take a look at this. This is a Harvard Mark II. This is one of the world's first programmable computers. There were a couple before this one, but this is one of the more famous ones. So this was built at Harvard under the leadership of a really cool woman named Grace Hopper. And this is what a computer used to look like. Now, to give you an idea of scale, this is a normal sized room, and this is about half of the computer. This is all one big computer. And the processing power of this computer is nowhere near the processing power of the computers we have today. Not even our little watches that we have on our wrists. So just looking at this picture, it's pretty impressive, right? This is what, 50, 60 years ago, and now we're wearing computers on our wrists, carrying them in our pockets. It's pretty impressive. Anyways, back to the bug story. So these computers, as you can tell, there's a lot of sort of physical components. Some of these physical components are wires, and you'd have to move them around to actually program the computer. There's also these switches, which are called relays, which are these physical, they're switches that you'd have to move around to get programs to do different things. So the term bug actually dates back to when this computer was running. It was running a specific program, and the output just didn't make sense for what they programmed through the switches and the relays. They spent hours and hours trying to figure out what was going on, and then they found the problem. Problem was this moth. So the first recorded bug, the first recorded error in a computer program was a literal bug. It was a moth that was wedged into one of the relays. And you can see here on this note, relay number 70, panel F, moth and relay. So the first bug was a literal bug that was discovered by Grace Hopper's team when they were working on the Harvard Mark II. Just to put in a little plug about Grace Hopper, she is one of what a lot of people consider the founding programmers of our time. She was a Rear Admiral in the US Navy. She's a pretty cool woman. I recommend reading up on her if you're interested in history at all. I've added a link on Canvas to Grace Hopper sort of Wikipedia page so you can read up more about her. But she has a pretty cool history. I recommend looking into it if that's something that you'd be interested in. One other sort of fun thing, this is a selfie of me. Yes, I'm a real person. I'm not just the voice behind your computer screen. This is a selfie that I took about 2 years ago when I was visiting Harvard. So if you go to Harvard and you go to their CS department building, they have the Harvard Mark I just sitting there in the building. So the Harvard Mark I is the precursor to the Harvard Mark II. So it's not exactly the same computer, but it's still pretty cool. So if you're ever there, I recommend checking it out. Alright, so again, we will talk more about writing and debugging code throughout the term. Next, I want to talk about testing the program. So this is something that you should be doing as you are writing code. It is much better to write a line or two or a couple lines at a time and test your program then. Testing, you're looking for two things. You're looking for, one, does the program run without errors? If it does, awesome. That's more than half the battle. And you're also looking for, does the program do what I'm expecting it to do? So for example, if you're doing math calculations, is it calculating them correctly? So again, testing is something that you should be doing as you are writing code. It's much easier to deal with bugs and to do the debugging process if you run and test your program often versus if you write a wall of text and then you try to run it all at once. Then it's a lot harder to find specific bugs. So testing the program is something you should be doing as you are writing and debugging code. Next stage I want to talk about is documenting code. So this is super important for a couple of reasons. It's important for, one, a real-world scenario where generally if you're working on a large project with a team in a company, there will be multiple programmers all working on the same code. So it's very important to document your code. Now what I mean by document your code, you're sort of going to write a manual or a guidebook for what your code is up to. So it's just a written explanation of your code in plain written English words or whatever your native language is. And it's there to help you and it's there to help other programmers. It's also really important for your own records. So for example, if you are working on a larger project, even if you're the only person working on it, and let's say you need to take a break, right? You come back to your code, it's much easier to sort of work on where you left off if you left documentation for yourself. One of the easiest ways to do this is to add what we call comments into your code. So comments are something that you are going to put in the files themselves where you write code. And it's pretty cool because the computer, when it runs your code, it completely ignores comments. which is what we want, right? The idea behind documentation is it's for the human's benefit. The computer doesn't care about your documentation. The computer is just going to run the code exactly as you give it. The documentation is there for the human readers of your code, so the computer will ignore these comments. So in Python, the way you say, hey Python, I'm writing a comment, is you type this pound symbol or the hashtag symbol, depending on what generation you're in. So this pound/hashtag symbol, the way it works, once you type it, everything else that's on the rest of that line is going to be a comment. So this example right here, the first 4 lines, these are all comments. These are what I call header comments. It's there to sort of make it super easy to say, oh, okay, so-and-so wrote this. It's for this purpose. This is their email address if I need to contact them. So these are something that you will be writing on all of your assignments, a sort of explanation of what the program is, information about the school and the course that you're taking in, your name, your email address. Another way you can do comments, these are inline comments here next to this print hello world statement. Print hello world, this is some actual Python code. We will talk more about what this is and how it works later. What I want you to look at now is the comment in red to the right of it. So you can also put comments on the same line as code itself. So what I'd like you to do right now is go ahead and code this up. So at this point, if you don't already have Python installed on your computer, go ahead and pause the video and install it. Once you have Python installed, you're going to want to go to the folder where it's installed to. If you're on a Mac, it'll be under Applications. If you're on a Windows computer, it'll be under your Programs folder. So go ahead and find Python, and then look for the program called idle. So idle is what we will be using to write code in this class, to write Python code. Go ahead and open up idle. This first window that comes up, this is the shell. So something to note about the shell, whatever you type into here, it won't actually be saved. Alright, so the shell is really good if you want to test one line of code really quick to see what happens, but it won't actually save that code. So for the purposes of this class, most of the code that you'll be writing, you'll want to save. So to do that, instead of typing stuff into the shell, you'll go to File, New File, and type stuff here in this file instead. So go ahead, open up a new file, and then let's type out this stuff here into the file. Of course, for the author place, go ahead and write your name, and make sure when you turn in your own assignments, you include your last name as well. Alright, so those are our header comments. Again, those are there just for the benefit of the humans reading this. And then this right here will be our first line of code. So make sure when you type this part right here, this print hello world, make sure it matches exactly down to all the punctuation. These parentheses are important. These quotes are important as well. So make sure yours matches exactly. Python is very specific, and in fact most programming languages are very specific about punctuation, capitalization, all that fun stuff. So go ahead and type this up. Once you have, go ahead and save your file. I recommend for this class to have a folder specifically just for this class so all your code can stay nice and organized. So go ahead and save it there. we'll go ahead and save it as hello world. And something that I'll point out is Python files all have a .py extension that will be added automatically when you save stuff in idle. That extension is just like how Microsoft Word documents have a .doc or a .docx extension. Same sort of idea. So go ahead and save that. Once your code is saved, to actually run it and to see what happens, you're going to go to Run and then Run Module. You can alternatively also press F5. So run module, and there you go. You just wrote your first code. Yay! I will say, if you did have any issues, any errors that came up, so for example, if I get rid of this parentheses and I try to run it, I will get an error message that looks like this. That's okay. That's a bug. Celebrate your bug, and then go back, fix the mistake. So make sure if you do get any of those issues, any of those errors, make sure everything here matches exactly. That said, if you still are getting errors and you're not sure why, go ahead and send me an email. I'm happy to help with that. You're also welcome to post your code for this specific demo to the course questions page on Canvas. This is code that you won't actually be turning in, so it's okay to go ahead and post your code for this specific demo to that. But hopefully at some point this will come up. Again, if you have any questions, send me an email. Alright, let's go back to what we were talking about with the programming process. So we've seen comments now. We've written a little bit of code. The last stage of programming is maintaining code. Now, unfortunately, we won't get a lot of practice of doing this because maintaining code is sort of a long-term thing that you have to do. The idea behind it is once you create code and publish it so the world can use it, you want to sort of keep an eye on it, right? Make updates if you need to, respond to feedback from the users, and generally just make sure it's doing what it's supposed to do. So again, these are the stages of programming. Again, they're not in any particular order. You generally will jump around between these stages. It is extremely important though to not skip that design and plan phase, so please make sure throughout the quarter that you're spending a little bit of time, pen and paper, designing and planning your code before jumping into writing code on a keyboard. That said, if you have any questions about this material, feel free to post on the discussion forum on Canvas or send me an email, and I will see you all in the next video.